Welcome back to the start of a new week. We are well into our unit on climate change. And where we started this week, where we are starting this week, is to tie together these three units that you've been working on. States of matter, which is about solids, liquids, and gases, and what makes them change from one to another. Remember, any substance could be a solid. Gold, we usually think of as a solid, but it could also be a liquid or it could be a gas. During the horrible wildfires that occur around the country and here in Oregon, people go back to their houses and they look for valuable things like jewelry that may have been lost. And we may not think about it all the time, but if there was a gold necklace or a gold ring or a gold bracelet that got caught in a house that burnt during the wildfire, that gold is no longer there. House fires, forest fires are so hot that they actually take the gold and make those atoms and molecules of gold move so fast that they change to a liquid and then change to a gas, and the gold atoms just disappear up into the atmosphere. So we don't often think about that, but we'll take a look at that a little bit more today. All right, so you should be, at this point, making sure that you are working on your climate paper this week. Remember that that is a big assignment. And so there, let's see. Your climate change paper. Okay, so remember that what you should have done already is to have chosen a region, and in my example, I chose Germany because that's where my grandparents were from. Then I picked wildfires and sea level change as my indicators. And then I wrote about background information about forests in Germany and sea level in Germany. And I wrote about why those are indicators of climate change, how they relate to climate change. Okay, that's some research. Describe the region of the world, so I would have described where Germany is and what the climate was like a long time ago. That's number 5 there, 100 to 500 years ago. This week, you should be starting to work on what is the current status. In other words, what is the current status of wildfires in Germany? What is the current status of sea level? How is it affecting the German people, their economy, their way of life? Okay, and then in a few days later this week, you should be working on predicting the status. In other words, thinking about 100 to 200 years into the future. Could you go further? Sure, you could go 1,000 years into the future or 1,000 years ago if you wanted to. Make sure that you're adding in concrete detail along the way. Keep in mind, I want you to tell me a story. I want it to be at least 500 words. And I want it due the end of the month. All right, so let's move back over to our unit. We've been working on states of matter, and one of the things that I wanted to talk about on this Monday is that it may seem that we've been doing some very different things. We started out talking about climate and weather, and you did the first Bitmoji and you read about sea level change and you read about some other things and watched some videos. And then I switched it up and we did kinetic molecular theory, that as we add more energy, the molecules and atoms move faster. And now that connects to states of matter, where if we raise the temperature, we change the state of matter, okay? Because we make those atoms and molecules move faster. All right, so what does all that have to do with climate change and weather? Well, keep in mind that climate change is about things that have to do with temperature. So as temperature is changing, we're changing substances from gas to liquid, liquid to gas. Okay, we're increasing evaporation rates. That's going from liquid to a gas. We're changing the way that sea ice behaves, which is changing a solid to either a liquid or a gas. You may have run across the word sublimation. Sublimation, that's when a solid changes to a gas without going through a liquid. And today we're going to look at how is that even possible. So at any rate, climate change, weather, states of matter, kinetic molecular theory, okay? All of those all relate to each other. So what I want to do now is take a look at that one about phase change diagrams. There was a little video that I showed you about phase change diagrams, and I just want to describe what those look like. So we're going to start with a graph, and on our graph we're going to put temperature down at the bottom, and we're going to put pressure along the y-axis, x-axis, and y-axis. All right, I'm going to pick sea level, okay, right here, and at sea level our pressure is 1 atmosphere. Now we're going to go some temperatures. I'm going to start out with 0 degrees Celsius, 100 degrees Celsius. And so what happens as we go from 0, okay, well, we know that it's a solid over here. We know that it is a liquid in between. And we know that it's a gas up in here, okay, if we were to just put kind of a horizontal line right through there. Well, actually, what happens is we have a graph that looks kind of different. It has 2 lines on it, one that goes this way, and a branch off that goes that way. And so what happens is that everything in this area is a solid, everything that's in this area is a liquid, and everything that's in this area is a gas. All right, so if we had, and I'm going to change colors one more time, if we said, well, I'm going to do some an experiment, and I'm going to pick a gas at room temperature, well, let's see, a liquid at room temperature right here, somewhere in there, at 1 atmosphere of pressure. And now I'm going to take that and reduce the pressure. How do I do that? Well, I could go up in altitude. Well, what that says is if I go and reduce the pressure, let's say to 0.3 atmospheres, wow, what that says is I would turn my water into a gas without changing the temperature. Is that possible? Absolutely. We can reduce the pressure and turn it directly into a gas. Okay, so if that's possible, we could reduce the temperature, but instead of changing to a solid at 0, it doesn't even go to a liquid. It goes straight from a gas to a solid at that lower pressure, which might be way, way, way as we're getting towards outer space. And if we go another way, we could start with that liquid, and I'm going to choose a different color here, orange this time. We could start again with a liquid and say, well, I'm going to leave it at the same temperature, but this time I'm going to just raise the pressure. Wow, and by raising the pressure, I change it to a solid, and I haven't changed the temperature. So that's how these triple point diagrams work. Another interesting fact with this is if you thought about making a horror movie at some point in your life, what happens to a person in outer space if they go out in space without a pressure suit on? Well, people are 78% water, and so that says that we would go from a liquid to a gas. We would boil. So that person, as soon as they step outside the spaceship, they would start to boil. And that's a pretty ugly kind of thing. You've never seen that in a science fiction movie. But if you were doing real science, that is what you would see. All right. So for tomorrow, what I want you to be looking at is going back and finishing up and working on states of matter. I'm going to give you some time to catch up, okay? States of matter, and your climate change paper. That's what you should be working on for Tuesday.